Okay, another way I can prove triangles congruent is by angle, side angle. So again, if I read the definition, I have if two angles and the included side of one triangle are congruent to two angles and an included side of another triangle, then the triangles are congruent. So in this situation, the side is connecting the two angles. So we're looking for the side that is connecting the two angles that you actually have. So if angle A is congruent to angle D, the side, which is AB, is congruent to DE, and then an angle, which is angle B, is congruent to angle E, then I can say that the triangle ABC is congruent to triangle DEF by angle, side, angle. Example. I know that SQ bisects that angle. SQ bisects. What does that mean? Bisects. Okay, so that is given. Bisects, I got to remember, means to cut in half. Or in other words, cut into two congruent parts. Okay, so SQ bisects this angle. RQT is being bisected. That means those two pieces are congruent. And it's also bisecting angle RST, which is that angle. So I know this angle is also being bisected or cut in half. So that was also given. I know that angle RSQ is congruent to angle TSQ. Something's wrong here. This was not given. This is because definition of bisects. Sorry. Getting ahead of myself. And I know that these two angles, RSQ and TSQ, are congruent by the definition of bisects again. And I know that QS is congruent to itself by the reflexive property. That little piece. So I have a congruency symbol here, and these are angles. I have a congruency symbol here, which are angles, and I have congruency symbols here, which are sides. Now, look carefully down the left side. I have angle, angle, side. I am not putting angle, angle, side here. I need to go back and look at my diagram. I have an angle. Here's the included side, or the side that is connecting both angles, and this angle. So it is proving them congruent by angle, side, angle. And yes, that does make a huge difference. So these can be out of order. So you need to look at your diagram to verify which way that you are actually proving these congruent. Okay, I'm going to skip over to this bow tie. Zoom in here a little bit. So this is a from scratch. So angle BAC is congruent to angle DEC, that is given. Angle BAC, so that means this angle, is congruent to DEC, which is this angle. And I know that that proves an angle congruent. I know also that C is the midpoint of AE. So I got to think about that. C is the midpoint of AE. C is the midpoint of AE, which means that these are going to be congruent. So I need to write that down. So AC is congruent to CE because of the definition of midpoint. A common error is people will want to put a side here because they know that sides are going to be congruent. But this is not a congruency statement. This is the congruency statement. So this is where this is a side. And what else am I going to think of? Well, this is that bow tie that you were kind of warned about, if you will. Anytime you have a bow tie, you are going to have vertical angles. So I know that angle BCA is congruent to angle DCE. Remember, you cannot use just C because there's a whole bunch of angle C's here, so you have to use your 3 points because vertical angles are congruent. And so now, asked to prove triangle ABC congruent to triangle EDC. Okay, do I have my 3 parts? Nope. Oh, I missed an angle here, so we're going to label that by angle, side in between, and the angle. So angle, side, angle.